Have you ever stopped to think about what actually happens when you click Buy Now or post a photo or search for, well, anything online? You're tapping into this massive, invisible architecture that runs our entire digital lives. Today, we're going to pull back that curtain and take a look at the system underneath it all. And trust me, the scale of it is just mind-blowing.
To really get why this system is so important, you first have to understand the scale of the problem. Just look at this number, 463 exabytes. That's the projected amount of data that's going to be created every single day worldwide by 2025. To put that in perspective, that's like 200 million DVDs worth of information every single day. It's just an insane amount of stuff. And look, this isn't just some cool fact about modern technology, it's a monumental challenge. We're not just, swimming in data anymore, we're literally at risk of drowning in it. This massive, chaotic ocean of information. That is the core problem that needed a seriously brilliant solution.
So this chaos, it really breaks down into a few key issues. First, like we just saw, the sheer amount of data is just exploding exponentially. Second, this data is coming from everywhere. It's scattered, it's unstructured, a total mess. And finally, when you have that much messy data, you've got huge security and quality problems. How do you even protect it? How do you know if any of it's even accurate?
So, how in the world do we survive this data ocean? Well, we need a rescue raft. And in our digital world, that raft, that elegant solution that brings order to all this chaos, is the database. It is absolutely the hero of our story today.
So what is a database, really? The official definition is an integrated collection of logically related records or objects. Yeah, okay, let's make that a lot simpler. Just think of it like a highly organized digital library. Instead of having a giant, messy pile of books on the floor, you've got a whole building with shelves, sections, and a perfect catalog system where every single piece of information has a specific, logical home.
And here's what that organization actually looks like. This is a simple table from what's called a relational database. It kind of looks like a spreadsheet, right? But believe me, this is a spreadsheet on steroids. Every row is its own unique thing, and every column is a specific piece of information about that thing. And there are strict rules here. The item underscore no has to be a number, the item underscore name has to be text. It's this rigid structure that turns all that chaos into clean, reliable, and super fast searchable information.
Okay, so we've got our organized library, the database itself. But how do we actually use it? How do we find a book, or add a new one, or update the catalog? For that, you're going to need a manager.
And that brings us to the next critical piece of the puzzle, the Database Management System, or DBMS for short. And the analogy is perfect. If the database is the library, then the DBMS is the librarian. It's the software that manages absolutely everything. You don't just waltz into a library and start yanking books off the shelf yourself, right? No, you interact with the librarian who knows the system, enforces the rules, and handles all of your requests.
The DBMS basically acts as a gatekeeper. So when your app on your phone needs something, let's say it wants to look up the price of that laptop, it doesn't talk directly to the raw data. Instead, it makes a formal request to the DBMS. The DBMS figures out what the app wants, goes into the database to get it, and then hands that information back to the app. It's this essential middleman that makes the whole thing work securely and efficiently.
All right, so if we're going to make requests to our librarian, the DBMS, we need to speak a language it actually understands. We can't just shout, "Hey, get me that laptop thing." We need a precise, universal language to communicate.
And that language is SQL. It stands for Structured Query Language. It is the global standard for talking to these kinds of databases. You can just think of it as the official set of commands our librarian understands. Whether we want to create a new shelf, add a new book, or just find some information, we use SQL to give those instructions.
I know this all might seem a little abstract, so let's make it real. We are going to actually see, step by step, how we can use SQL to build our own tiny piece of a database, our own little digital shelf, using these concepts as our building blocks.
Okay, so our very first command in SQL is create table. With this one line, we're telling the DBMS to build a brand new table. We give it a name, inventory, and then we provide a super precise blueprint for each column. An item number that has to be an integer, an item name, a unit price, and an inventory count. We're building the structure first.
And just like that, poof, the command is executed. Instantly, we have a perfectly structured but completely empty container for our data. The shelf has been built, it's been labeled exactly to our specs, and now it's just sitting there, ready for information. Next up, we need to actually put something on our new shelf. This is our second command, insert into. We tell the DBMS which table we're talking about, our inventory table, and then we give it the exact data for our first item, in the correct order. Item number 2321 is a Dell laptop that costs $1,500, and we have 56 of them in stock.
And there it is. That's the result of our command. The data is now perfectly filed away in our table exactly where it belongs. See what we did? We took a random piece of chaotic information and, by using a clear structure and a precise language, we gave it a permanent, organized home.
So let's zoom back out. That simple two-step process we just walked through, creating a structure and then inserting data into it, that is happening billions, probably trillions of times a day all around us. This simple system is the invisible backbone of your social media feed, your banking app, online shopping, flight reservations, pretty much everything. It's the engine of order in a world of pure digital chaos.
So what this all really means is that every single time you like a photo or search for a video or buy a product, you are starting a conversation. A request is sent in a language just like SQL to a librarian, the DBMS, which then goes and talks to a vast digital library, the database. So, now that you understand the basic grammar of that conversation, what do you see differently the next time you click?